going to take a look at some log properties. Okay, there's 5 properties that we're going to look at today, and they work the same in log form as they do in natural log form. So we're going to look at both of those as well. So if we look at the properties of logs, there are 5 properties we're going to look at. So the first one, we know that log, we're going to use a general form every time, and then we'll get into some examples. So log base A of 1 is equal to 0. How do we know that? Well, we can always change forms, and we know that because, I'm going to use the abbreviation because, our base is A, our exponent, because logs are equal to exponents, is 0, and anything to the 0 power is always 1. So if you have a log of anything, any base of 1, your answer will always be 0. Because in exponential form, we know anything to the 0 power is 1. So since you can switch back and forth between log and exponential form, those rules are very similar for exponent rules as log rules. They're very much related. So if I have log base A of A, so if the base matches my result here, that's going to equal 1. And that's going to come in handy. We're going to use that property a ton. We're going to change things so that becomes that property. And that's because anything to the first power is itself. So if we have a base of A, the exponent's 1, it's going to be itself. So that's really nice. The third property that we want to know about logs, or we're going to use, is that if I have log base A of A to some exponent power, my solution will be that exponent power. Because what happens, we're going to switch this into exponential form. Let's say that this was a number here, and then we needed to solve for that number would be the answer. So if I have my base is A, as you can see here, my exponent is x, and it's going to equal that result of A to the x. So that rule holds true for both log and exponential form. Now this next rule, actually we're going to start it in exponential form because it makes more sense in exponential form. So if I have a base of A, and I raise that to a power of log base A of, I think we're going to go with x. Yeah, x. So if my exponent on my base of A has the same base on the log as that base, then my result is actually going to be x. Now, the reason this works is because if I change this exponential equation into log form, this works because if I have a log base A, so here's my base, I know that logs are equal to exponents, so my result is the only thing left of x equals log base A of x. Oh, look at that, they're actually equal to each other. And my fifth property is actually called the one-to-one property. We're going to do a whole day on that a little later. But in this case, very simply, we can use it. Log base A of x is equal to log base A of y. So if the bases are the same, then we know that x and y have to be equal to each other. So if I have two logs where the bases are the same, maybe this was a number and this is unknown, those two would have to be set equal to each other to be able to solve. So then we know that x is equal to y. We're going to take a look at a couple problems here that use these 5 properties. So make sure you got those written down because we're going to refer back to them every once in a while for these next few problems. So my first example here, let's take a look at log, example 1. Log base 2 of 64. We want to solve this. So we're going to try to change 64 into something that has the base of 2 so we can use one of our properties. Our goal is always to get the base of our log to match the base of that term whenever possible. So I'm going to need to change 64 into something. So if I change this into a log base 2 of 2 to the 6th power, as 2 times 2 times 2 times 2 times 2 is 64. Then I see that my base matches, and so my result is just going to be 6. So that would actually use the let's see what property was that? The third property, where your base matches, so your answer is just your exponent. Now, if that was a little confusing for you, you can always change forms and try to figure out what your solution is. So 2 is our base to the power we don't know is equal to 64. You can play around in your calculator a little bit and figure that out, but there is no way to take the xth root of that to figure that out. That's why we use logs, to solve for exponents. So in this case, you would figure out that x is equal to 6 because 2 to the 6th power is 64. All right, let's try another one. Our next example. We've got log base 25 of 5 is equal to, well, we want to try to see if we can change 5 in anything with a base of 25. Actually not possible. So what we're going to do instead is just change forms. 25 to the what power gives us 5. Well, what's happening here to this 25 to get a 5, we're not dividing by 5. I know that's tempting to say, but what exponent could we give? There's no exponent that gives us an operation of division, but there is an exponent that will square root this. And so a square root exponent would be 1/2. So the square root of 25 is 5. So x has to be 1/2. Remember fractional exponents? If you have fractional exponents, 1/2 is equivalent to the square root, 1/3 is a cube root, 1/4 is a fourth root, etc. So we're going to use those quite often here. All right, this next one, example 3. We've got log base 7 of 1/49. And now I'd like you to try to change 1/49 into something that has a base of 7, because that's going to really help us. So hopefully you can come up with log base 7 of 1/7 squared. We still don't have those bases matching perfectly, so we're going to change this into log base 7 of 7 to the -2. Remember, if we move anything up to the numerator of a fraction, that changes it to a negative if you change levels of a fraction. If it was a negative up here, moved it down, it'd be positive. If it's a negative down here, moved it up, it'd be positive. But here, this is positive, moved it up, so now it's going to be a negative exponent. So we're using our property, if we have 7 and 7, those match, then our answer is just -2. Take a look at our next example. Hopefully this one's pretty easy for you. Log base 4 of 4 raised to the -0.038 power. So, just like this last one, if 4 is matching on our base of our log and our result here, then our answer is just -0.38. Next example, we're going to use a different property this time. So we're taking a look at log base 19 of 1. We know that anytime we have 1 here, our answer is always going to be 0. That was that first property we did. Because 19 to some power that equals 1, well, anything to the 0 power always equals 1. So x has to be 0. My last example, like this, example 6, if I have, let's see, 4, so this is that exponential one, with a raised to the log base 4 of 3, and my answer here, these two will cancel out, leaving me with just 3 as a solution. That's that fourth property there. All right, let's try to solve a few log equations, or some unknowns. Let's do a few of these. So if we look at, let's see, how about log of base x of 81 is equal to 4. So we need to switch forms to solve, and then we're going to try to figure out what x is. So if I switch forms here, I've got x to the 4th power equals 81. The only way to undo a 4th power is to take the 4th root of it. Let's take the 4th root on both sides. And I get x is equal to 3. My next one here, log base 4 of x is equal to 3. I'm going to change form so that I can solve. So 4 to the 3rd power equals x, and 4 to the 3rd power is 64. This next one, log base 10, also known as common log. Let's just take a pause real quick and talk about this. So if I have log base 10 equal to 0, this is called common log, which is also, if you just see log of x with no base written, you can assume that the 10 is there. So if there's no base, then you would assume log has a base of 10. And you'll see that in our next unit as well, our next lesson as well. Okay, so anyway, going back to this one, if we change forms for this one, we have a base of 10 raised to the 0 power, so x has to be, anything to the 0 power is 1. So x has to be 1. All right, one more, then we'll move on to natural log. So log base 2 of x is equal to log base 2 of 4. This is a real quick one-to-one property one. This is the fifth property we just looked at. If we have the same base, then our two result pieces have to be the same. So x has to be equal to 4. All right, we're going to take a look at natural log. And natural log works exactly the same as regular log. So the properties are the same. The only difference is when we look at natural log, so natural log would have a base of e, let's just say e to the x equal to y right now. And so instead of writing natural log of e, because e can be confused as a variable, e is a number. It's very similar to pi, non-terminating, non-repeating decimal, 2.72, I believe, is how that starts out. So instead we write natural log of x equals y. So we know that this means that there's a base log with base of e. So we know that. So those properties, those 5 properties work the same. If I have natural log of 1, it equals 0 because we have e to the 0 power, because e to the 0 power equals 1. So all these properties are going to work exactly the same. If I have natural log of e, the bases match because it has a base of e, so that's going to equal 1. If I have natural log of e to the x, the bases match, so my answer is just x. These are all those same properties. If I have e to the natural log of x, again, those match, so my answer is x again. And last one, if I have natural log of x is equal to natural log of y, then x equals y. So all those properties hold true for natural log as well. So now we're going to do a couple of natural log examples. So if I have natural log of e, of 1 over e, let's do that. I have natural log of 1 over e. Then I want to move this to the numerator. It's 1 natural log of e to the negative 1. So now my base matches. That's always my goal. Change those bases so they match. My answer is negative 1. Next thing I want to do, I'll take a look at natural log of e to the 3rd power. This one's even simpler. We have those two that match, so we get a 3. There's our 4th property, e raised to the natural log of 5. Since these two match with the same base here of e, base here of e, we get 5. And finally, let's just throw in a 1-to-1 property for good measure. So natural log of x plus 2 equals natural log of 10. So then if they both have the same base of e, we have x plus 2 is equal to 10. So x equals 8. So that's it.